Hello everyone, first of all let me introduce myself. My name is Rana Hapsari from Institut Teknologi Bandung. Now I will to explain about my research with the title is Correcting Bias GPM-IMERG Precipitation over Brantas Watershed, Indonesia. Now we are moving forward to the introduction. The global precipitation measurement GPM is newly developed as satellite products with the integrated multi-satellite retrieval for GPM, or we can call it IMERG. And the IMERG algorithm produces three types of product. First is early, late, and final runs at half hourly and 0.1 degree resolution starting in March 2014. And then the IMERG final run product provides more accurate estimation and considered as the research level product. According to ASCA in 2019, there are few investigations of GPM-IMERG product performance over Indonesia on a basin scale, and therefore this study aims to validate it and correct it of GPM-IMERG rainfall product on a basin scale, specifically on Brantas Watershed with one temporal data. It is monthly, and the correction were conducted temporally and spatially. And next, the data that we use in this research are daily rainfall data on gauge network of 74 stations over Brantas and daily rainfall GPM-IMERG version 6, which is the new version of GPM-IMERG with final run operation. And this data from January 2015 to December 2019. Also, we use digital elevation mapping dam Brantas with the resolution is 8 meter. For the research method, for ground validation includes coefficient of correlation, root mean square error, NASA cliff efficiency, relative bias, probability of detection, false alarm ratio, critical success index, Hidal scale score, and the bias. For the bias correction, we use quantile mapping method, and for the correction factor over Brantas, we use multiple linear regression method. This method has been made following some of the most acknowledged methods cited in the literature that used for ground validated and corrected of satellite products. Next is about research area. The Brantas River Basin is the second largest river basin in the Java Island. It is in Java province, and the Brantas River stretches to about 320 km in length and has area of about 12,000 square kilometer. And for the average annual rainfall over Brantas is around 2,100 mm. The variation of the annual rainfall is run. It's large, about 2,250 mm in a wet year, and for a dry year is 1,850 mm. For the annual rainfall in the high elevation is generally high, around 3,000 to 4,000 mm according to Pola Brantas in 2020. And then the results and discussion of ground validation. Generally, the evaluation of GPM-IMERG for monthly rainfall shows a good agreement between two datasets with high coefficient of correlation, and the value of the NSA of 0.8, and the relative bias shows a positive value of 19%. This value indicates GPM-IMERG generally overestimate precipitation over Brantas. And for the elevation analysis, the Brantas watershed are divided into three elevation zones. The relative bias in the highland shows the lowest value of 11%. However, in the medium land and the lowland shows high value with by 23% and 20%. According to the LU, in 2019, the GPM-IMERG shows an underestimates precipitation in the highlands and the mountains. And next, the result and discussion of bias correction. The quantile mapping method was used for bias correction by using 5 rain probability classes. And in this stage, we're using the GPM-IMERG rainfall data from January 2015 to December 2018 because we used 2019 data for the verification process. And the performance of corrected GPM-IMERG was then evaluated. The NSA has increased from 0.81 up to 0.83 in the highland. In the medium land, the NSA has increased from 0.78 up to the 0.82, and the lowland, the NSA has increased from 0.85 up to 0.86. The relative bias has greatly reduced for its elevation zone after the bias correction, and the bias value for its elevation zone close to the 1 indicates the corrected GPM-IMERG accurately to the observed rainfall. And overall, for the corrected GPM-IMERG shows better performance than the original one. Next is the correction factor. The multiple linear regression method aims to be obtained to the equation used for correction factor over Brantas, and in this case, the equation includes longitude, latitude, and elevation. And then based on map of correction factor, we can see the value of the correction factor has decreased in the downstream area, and the range of the correction factor over Brantas watershed overall is 0 until 1.3, and for the higher the probability of exceeding the event or for the lower rainfall, the correction factor will be more varied. This condition occurs mainly in 3 classes of rain probability. And the last is the conclusion about this research. Based on evaluation indicates the correlation of GPM-IMERG monthly rainfall and rain gauge is relatively good. The GPM-IMERG rainfall shows an underestimate in the highland and the mountains with the elevation is more than 500 meters above sea level. Meanwhile, in the lowland and the medium lands with the elevation less than 500 meters shows an overestimates precipitation. But generally, as well as the GPM-IMERG shows an overestimate over Brantas watershed. And the quantile mapping method can improve the original GPM-IMERG at monthly scale and suggesting that correcting effect is most prominent in the medium land, which the elevation is about 100 meter until 500 meter, and the compared corrected GPM-IMERG and the original dataset reveals that the corrected GPM-IMERG has better performance than the original one. And the multilinear regression method was used for the correction factor over Brantas and is influenced by spatial parameter including latitude, longitude, and elevation. The combination of these 3 spatial parameters produce a different correction factor for each grid, and for lower rainfall, 41 until 100% of rain probability, the correction factor will be more varied. Okay, thank you everyone for your attention. Have a great day.